Hey guys, Mr. Smith here, and we're doing a short review lesson on solving right angle triangles for angles. So I have another motivation problem for you. My brother-in-law Ryan's back at the job. Um, a new belt that he built previously now has a limit on how steep it can be. So the belt is 20 meters long, and we know that it reaches 2.4 meters above ground. But evidently, there's a building code that says that the steepest that this conveyor belt can be must be 7 degrees. So we want to see if this belt is up to code. We want to find the value of this angle. I'll call it theta. So in our last lesson, we reviewed how to find sides, but how do you find angles using SOHCAHTOA? Quite similar to how to find sides. Choose an appropriate ratio. So we're trying to find this angle. The 20-meter side, because it's the longest side, is always hypotenuse across from the 90-degree angle. In our 2.4-meter side, because it is across from the angle we're trying to find, it is the opposite side. So the ratio that will help us solve this problem is the sine ratio, but how does it look when we're solving for an angle and not a side? I will show you. So we, just like before, we plug in what we know. This time we don't know the angle, theta, but we know the opposite side is 2.4 and the hypotenuse is 20. Depending on the class, I show a lot more steps or I do it very quickly. I'll show a lot of steps initially here, and then I'll show you how you can shave off some steps as you go. So we're just going to do that division, 2.4 divided by 20. I should know that, but I'm using a calculator, so about 0.12. I just want to add a note. If you are doing the step where you do the division, I usually keep 4 decimal points. Decimal points, just to maintain a lot of accuracy. Here I got exactly 0.12. But how do you get at this angle? The sine of an angle is 0.12. Do we just have to do like guess and check and just keep plugging in angles till we find something close to 0.12? No, your calculators have a function. It's called the inverse sine function, where you can do the inverse sine of 0.12, and it will spit out the angle for you. So usually that involves on your calculator pressing shift or pressing second. If you're still using an iPhone or whatever, what's wrong with you? Get a calculator. I'm sure that you can do it, but I don't know how. Get a calculator. Inverse sine of 0.12. So I got about 6.89 degrees, and I can show you. You can see what I have punched in. So I have my second function button. You can see here it's orange. So I did second function. Sine, you can see in orange it says sine inverse. Punched in my decimal and it spits out the angle. I usually keep around my angles to 1 decimal place. And so what we have shown is that the angle is actually less than 7 degrees. It's not too steep. It's up to code. I'll just put a little concluding statement in here. Ramp is up to code. Right. So what we want to do in this review lesson is just get more comfortable solving for angles, get that skill back, because a lot of what we do in the 3U course relies heavily on having a good mastery of right angle triangles and SOHCAHTOA. So let's try a couple more. So can you guys decide on the appropriate ratio and give these a go? Maybe you want to pause the video and try them on your own. If you want to go through them with me, that's okay too. We're looking for the angle theta in this triangle. The 10.2 kilometer side is adjacent or next to that angle. The 20.2 kilometer side is across from the triangle from that angle. It's the opposite side. Of course, the hypotenuse is always the hypotenuse. And so we can see to solve for the angle here, we're going to be using the tan ratio. You can write down the ratio if you wish, or you can just go right to plugging in. So the tan of our angle is equal to opposite 20.2 over 10.2. I'm going to show you a lot of steps with this one and then kind of show you in the next example what I consider to be the minimal amount of steps. So 20.2 divided by 10.2 is approximately 1.9804. Again, keep a lot of accuracy. and our angle will be the inverse tan of 1.9804, whatever that is. Our calculators will do that for us. I got about 63.2 degrees. Again, I'd love if you pause the video and just try these on your own. If you've done that for B, that's great. Let's see what we get. And I'm going to show you in this one, I'm going to show you what I consider to be like the minimum steps you should show. So in this question, we're finding this angle theta, which means 25 degrees is our adjacent side. 52 centimeters is across from the right angle. It is our hypotenuse. So we'll be using cosine. So I don't need you to write out cosine is adjacent over hypotenuse all the time. I'm okay if you plug right in. But I want to see what you're plugging in. So the cosine of our angle theta is equal to the adjacent side, 25, over the hypotenuse, 52. And then here's what I would consider minimal work. Show me what you're putting in your calculator. So to get theta, we know we're going to be doing the cosine inverse of whatever 25 divided by 52 is. And those of you with a scientific calculator should have no issues punching that in. And it will just spit out your angle. And again, this is what I would consider to be the minimal amount of work. So as you can see, I can punch that in all at once, just making use of brackets on my calculator. Cosine inverse of 25 over 52. I got about 61.3 degrees. And as I mentioned, my way isn't the only way of doing things. If you have slightly different technique or style that shows the same work from your previous course, that is fine. So just remember, when you're doing finding sides, in our last lesson, you use the sine button, the cosine button, the tan button. But when we are finding angles, you're going to be using the inverse sine button. So whether that's shift or second function or whatever is on your calculator, or cosine inverse, or tan inverse. And I know I've seen some of you guys who have those little pocket calculators that can't do anything but add and subtract. Those will not help you. You need to get a scientific calculator. All right. Just like our last lesson, we're going to solve a triangle, choose a strategy, carry out that strategy. I also want to illustrate an idea that comes when you're solving triangles. Sometimes you have more information than you need. For example, in this triangle, I've asked for angle theta, but we know all three of the sides. So I want to do a quick exercise showing you guys that it doesn't matter which ratio you choose, you get the same answer either way. So with respect to angle theta here, 15 is the adjacent side, 20 is the opposite, 25 is the hypotenuse. So if we were to use the sine ratio, we would say that sine of angle theta is equal to opposite, 20, over hypotenuse, 25. And then angle theta would equal the inverse sine of 20 over 25, which I can just do with mental math there. It's 0.8. And we'll get our value for our angle. About 53.1. But we had a lot of information in that question. We could have used the cosine ratio as well. If you set this up, the cosine of that angle would be adjacent 15 over hypotenuse 25. And if you do cosine inverse of 15 over 25, which is exactly 0.6, you will see that you do get exactly 53.1. So I always like to show this example to just make sure that you don't get bogged down by choice. If you have more information than necessary, just pick a tool that works and then use it. Just make a decision and go. Some students can get paralyzed when they have choice, which is weird. You have more information, which is usually a good thing. All right. So the last thing we'll do is we're going to solve a different kind of triangle. In this triangle, we know two of the sides. We don't know any of the angles. So it's a bit of a different style than the previous lesson. So let's decide on a strategy. You have options. You just got to pick a strategy. So we do need the third side. Why don't we find the third side? We can do that right away because we have a trig tool that helps us with that. We're going to find BC, and I'll just put in brackets. We're going to use the Pythagorean theorem. I'll just put that in a little short form. Afterwards, we need to find either angle A or angle B. Just pick one. Let's find angle A. Go in alphabetical order. And which ratio will we use? Well, if we have 24, with respect to A, 24 would be the, and again, we're dealing with angle A here, would be the adjacent side. 26 is the hypotenuse. So we can get angle A using the cosine ratio. I'll just put cos. And then we don't need to use trigonometry or we don't need to use a complex tool to find angle B. Once we know two angles, we can always find the third. The angles add to 180. So now that we've decided on a strategy, let's carry it out. So I'll call that 2 and then 3. We're finding that. All right, let's do it. So for side BC, BC squared using the Pythagorean theorem. Because we are looking for a leg, we'll be doing the hypotenuse squared minus the other leg squared. I'll show a bit of work here. 26 squared minus 24 squared, I think, is 25. Nope, it's 100. I knew it would be a perfect square, though. And so, squaring both sides, you get BC is exactly 10 kilometers. That's nice. Okay, let's find angle A. Now, keep in mind, remember the example we just did. Now that we have all three sides, you could find either angle A or angle B, and you could use sine, cos, or tan. It doesn't matter. You just got to pick. So we're going to find angle A using cosine. So the cosine of angle A, the adjacent side is 24. Hypotenuse is 26. That doesn't give me a nice decimal, so I'm just going to write down A is the inverse cosine of whatever 24 over 26 is, because then I don't have to do any rounding, no intermediate steps. My calculator will just spit out what the angle is. About 22.6 degrees. And then finally, you could use sine, cos, or tan to find angle B, and it would work. But we could also just do B a little quicker by taking 180 and subtracting our other two angles that we know. And 180 minus 90 minus 22.6 is 67.4 degrees. We've solved that triangle. We know everything about it. All right, guys, we've done a little crash course in right angle triangle trigonometry. We'll, after our test tomorrow, we'll continue to review trigonometry for non-right triangles. But please make sure you try, or at least have a look at, the assigned practice. It's very important that you're a master of SOHCAHTOA and right angle triangle trigonometry for what we're doing in our trigonometry unit as we build on those skills from grade 10. Keep in mind the skills we have for solving right triangles. If you have two angles, you can always find the third. The angles add up to 180. If you have two sides, you can always find the third using Pythagorean theorem. And of course, in other scenarios where you have a side and an angle or two sides, you can use SOHCAHTOA. All right. So hope you guys enjoyed that lesson. Good luck in your work today. Hope you're staying well. We'll see you soon.